Hi guys, welcome to the 9-6 lesson, the quadratic formula and the discriminant. So our objective for the day today is going to be able to solve quadratic functions using the quadratic formula.
Sharpen your pencils now.
Yep, there's going to be a lot of writing today, so bear with us. Alright, the first thing we need to do is figure out what is this crazy quadratic formula. And I'm going to repeat it about 1,000 times today.
Memorize it.
You must memorize it. This is a question on the test. Is it a question on the final? It might be a question on the final.
Yes.
Now, to find the x-coordinate of one of your solutions using the quadratic formula, we take the opposite of b plus or minus the square root of b squared minus 4ac. We divide everything by 2a. All right, so I'll say it again. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. You need to memorize this formula. There's no way around it. You must memorize it. So let's use it. In order to be able to do this, it needs to be in standard form, so we subtract 21 from both sides of the equation for letter A. So we have x squared minus 4x minus 21 equals 0. So we're going to list our A, B, and C terms off to the side here. You do not need to do this every time, but as you're getting started, I suggest it just to make sure you're plugging in the correct pieces. So we start off with the opposite of B plus or minus the square root of b squared minus 4ac all over 2a. So now let's start plugging in our pieces of information. What is the opposite of negative 4? It is positive 4. Plus or minus the square root of b squared. So put negative 4 in parentheses, or you could just square it. Negative 4 squared is 16 minus 4 times a, which is 1, times negative 21, which is c. All divided by 2 times a, which is just 2. So now we have 4 times 1 times negative 21 is negative 84. So we rewrite 4 plus or minus 16 minus negative 84. Over 2, negative 84 minus negative. All right, so now we simplify inside that radical. We're going to get x equals 4 plus or minus the square root of 100. We have minus a negative, so we skew it, and we're still dividing by 2. Square root of 100 is 10. So we're going to have x equals 4 plus or minus 10 over 2.
Do you want me to show the step better?
Okay, so we have 4 plus 10 divided by 2 and 4 minus 10 divided by 2. 4 plus 10 is 14, divided by 2 is 7. 4 minus 10 is negative 6, divided by 2 is negative 3. So your two solutions are x equals 7 and x equals negative 3. Now the quadratic formula will work for all quadratic equations. Every single quadratic equation can be solved using the quadratic formula. Now sometimes it's a lot of work. If you look at x squared minus 4x minus 21, you might notice that you could factor that, and it'd be x minus 7 and x plus 3. So you're still going to get the same roots, you're still getting the same answers, but quadratic formula isn't always the easiest way. Sometimes it's the only way. So it would be x minus 7 and x plus 3. Using zero product property, we would still get the same two roots, which would be a positive 7 and a negative 3. So two different approaches to get to the same answers. All right, letter B, we've got x squared minus 3x minus 10 equals 0. So let's start off with just listing our a, b, and c terms. A is 1, b is negative 3, c is negative 10. So we're going to start by using quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So the opposite of negative 3 is positive 3, plus or minus the square root of negative 3 squared is 9, minus 4 times 1 times negative 10, all over 2. 2 times a, which is 2. So x equals 3 plus or minus the square root of 9 minus negative 40 over 2. Well, 9 minus negative 40, that's going to be a positive 49. So the square root of 49 over 2. We all know that that square root of 49 is going to be 7. So we have 3 plus 7 over 2 and 3 minus 7 over 2. 3 plus 7 is 10, divided by 2 is 5. 3 minus 7 is negative 4, divided by 2 is negative 2. Those are your two solutions, 5 and negative 2. Okay. Next up, we have letter C. X squared minus 2x minus 24 is equal to 0. So let's list out our a, b, and c terms. A is 1, b is negative 2, c is negative 24. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a.
Mr. Boland, do I have to write the formula every time?
Until you have it memorized, yes. When you can repeat it to me verbatim, as I have done 5 times already in this lesson, then you don't have to write it anymore. So we plug in our points. Ms. Zirzo forgot to replace the opposite of negative 2 is going to be a positive 2. So when we simplify inside of our radical, we have 2 plus or minus the square root of 4 minus negative 96. All of it's going to be divided by 2 still. So 4 plus 96 is 100. 2 plus or minus the square root of 100 over 2. And so square root of 100, still 10.
Silly pencil.
So we've got 2 plus 10 divided by 2, and 2 minus 10 divided by 2. 2 plus 10 is 12, divided by 2 is 6. 2 minus 10 is negative 8, divided by 2 is negative 4.
Will there always be a square number here?
Not always. It won't always be a perfect square. Sometimes you're going to have some ugly decimals here. It just so happens these first 3 are perfect squares. All right, next up we've got an a term. So a is 2, b is 2, and c is negative 12. So we start off with our quadratic formula again. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So let's substitute our values. The opposite of 2 is negative 2. Plus or minus 2 squared is 4. Minus 4 times 2 times negative 12. All over 2 times 2, which is 4. So we've got the negative 2 plus or minus the square root of 4 minus 96 4 times 2 is minus negative 96. All over 4. So again, now we have negative 2 plus or minus the square root of 100. So we have negative 2 plus the square, or plus 10 over 4, and negative 2 minus 10 over 4. When we solve those, negative 2 plus 10 is 8, divided by 4 is 2, and negative 2 minus 10 is negative 12, divided by 4 is negative 3. So our two solutions are 2 and negative 3. Okay.
Rest your fingers. Sharpen your pencil.
All right, so let's use the quadratic formula to find approximate solutions. Now, these are problems where we're not going to have nice, pretty whole numbers to work with. We're going to have decimals, and that's okay. Preferably, use your calculator on these when you're doing the calculations, and don't round until the very end. So we've got a batter hitting a baseball. The equation y equals negative 0.005x squared plus 0.7x plus 3.5 gives us its path, where x is the horizontal distance and y is the vertical distance. We want to know how far away from the batter the ball will be when it lands. So we need to find the zeros. We want to know when the height of the ball is 0. So we start off with the quadratic formula, the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. So x is equal to the opposite of b, so negative 0.7, plus or minus the square root of 0.49, 0.7 squared, 0.49, minus 4 times negative 0.005, times 3.5. Okay. All over 2 times negative 0.005. Now we can simplify inside that radical first, so we're going to have x equals negative 0.7 plus or minus the square root of 0.49. 0.49 minus negative 0.07 negative 0.007
Sorry, calculating kind of slow.
and we're dividing the whole thing by negative 0.01. Okay? So when we combine, we've got x equals negative 0.7 plus or minus the square root of 0.56 divided by negative 0.01. And the square root of 0.56 is going to be approximately 0.748. So we have x equals negative 0.7 plus 0.748 divided by negative 0.01. And that is going to equal negative 4.83 feet. All right, our second solution is going to be negative 0.7 minus 0.748 divided by negative 0.01. And when we simplify that, we're going to get x is equal to 144.8 feet. So the ball will land 144.8 feet past the batter, or we can discount that negative because the ball's not going to go behind him. Next up, we've got a batter hitting a ball, and we want to know when the height is going to be 23 feet off the ground. So we're going to set the problem up the same way using the quadratic formula. But first, we need to get it into standard form. So we're going to use the same equation, y equals negative 0.005 x squared plus 0.7x plus 3.5. And we're going to set that equal to 23 feet, which is what we want. So we're going to subtract 23 from both sides. And we're going to get that negative 0.005x squared plus 0.7x minus 19.5 is equal to 0. And now we can use quadratic formula again, which, if you don't remember by now, it is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to plug in our information. So we've got negative 7 plus or minus the square root of 0.7 squared, which is 0.49, minus 4 times negative 0.005 times negative 19.5, all over 2 times negative 0.005, which is 0.01, negative 0.01. So inside the radical, we can simplify. We're going to have square root of 0.49 minus 0.39.
Negative times a negative, positive.
All right, all over the negative 0.01. So x equals negative 0.7 plus or minus the square root of 0.1 over negative 0.01. Now the square root of 0.1 is going to be approximately 0.316. So we're going to have negative 7 plus 0.316 all over negative 0.01. And when we simplify that, we get x is equal to 38.38 feet. Our second solution is going to be x equals negative 0.7 minus 0.316 divided by negative 0.01, which is going to equal 101.62 feet. Now, does it make sense that we have two solutions on this one? Because that ball is going to be 23 feet high on its way up in its arc, and it'll be 23 feet high on its way back down again. So we do need both solutions for this case. So the ball has an arc. 23 probably won't be the vertex, but it'll be 2 points on the rise and the fall. Okay. All right, letter C.
You didn't leave me enough room to do letter C.
Oh, we've got enough room. I was able to do it.
Nobody can read your writing.
So we've got Greg, and Greg is tossing a baseball across the playground. The arc of the ball is modeled by the equation y equals negative 0.05x squared plus 0.75x plus 4, where x is the horizontal distance in meters and y is the height of the ball in meters. We want to know how far from Greg the ball lands. So we start off with the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Tired of me saying it yet? So we plug in our values. And Mrs. Zirzo is skipping some steps here. She multiplied 4 times negative 0.05 times 4, and she came up with negative 0.8. Negative point.
Don't skip steps.
Don't skip steps. And so when she's got the square root, or simplifies that radical, we're going to have square root of 1.3625. And this is all over negative 0.1. So the square root of 1.3625 is plus or minus 1.17. So we have negative 0.75 plus 1.17 divided by negative 0.1, which equals negative 4.2 feet. And we have negative 0.75 minus 1.17 over 0.1, which is going to equal 19.2 feet. So we're going to really only focus on the positive solution, because if Greg is throwing the baseball, it's probably not going behind him, because if you can see right there, that is Greg Maddux, Hall of Famer for the Chicago Cubs, and my personal favorite player. That might be on the test. All right, problem 3. Hey, I didn't give us much room to do the work. It's a good thing that we're just going to choose which is the most appropriate method for us to use. So we have taught you so far a few methods to solve these quadratics. We've taught you graphing. We've taught you to solve it by factoring. We've taught you square roots.
Is that what you meant or no?
No.
Okay.
Well, we taught you completing the square too, but we also taught you to just take square roots when we don't have a b term. And now we've taught you the quadratic formula, which is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So some of these methods will work for everything, some of them won't. And we want to figure out which is the most effective time-saving method that we can use for each one. So looking at letter A, we've got x squared minus 8x plus 12. Well, to me, that looks like we can factor that pretty easily. And so that's what we would do. We would have x minus 6 and x minus 2. We can factor that one. B, I see numbers that I can take I can take some square roots there, because I have an x squared term and I have a c term. So square root is going to be the best method to use for that one. Letter C, 5x squared minus 13x minus 1. Yeah, we're going to use the quadratic formula for that.
What is the quadratic formula?
I
don't remember.
The opposite of b plus or minus b squared minus 4ac all over 2a. Letter D, I have an x squared term and I have a constant. I'm going to use the square root method to solve that one. Letter E, 3w squared minus 17w plus 11. Yeah, I don't feel like finding factors of 33. We're just going to use the quadratic formula. And letter F, x squared plus 7x plus 10. That sure looks like something we've seen before, and I'm going to say factoring is probably going to be the easiest, most efficient approach to solving that question.
My finger hurts.
All right. last up for today, we have problem 4, using the discriminant. Now, the discriminant is a really powerful tool to answer the question, how many solutions am I going to have? When the discriminant is a positive number, you're going to have 2 solutions. When the discriminant is 0, you are going to have 1 solution. When the discriminant is negative, you will have no solutions. So we look at our A, B, and C terms. A is 6, B is -5, and C is 7.
-7.
-7, because we'll subtract. So we have 6x squared minus 5x minus 7 equals 0. So when we plug in our pieces, b squared minus 4ac, b is -5, -5 squared is 25, minus 4 times 6 times -7. So 4 times 6 times -7 is -168. And 25 minus -168 is 193. So we will have 2 solutions for this. All right, letter B. We've got our A is 2, B is 7, and C is -15. So we're going to have b squared minus 4ac. 7 squared is 49, minus 4 times 2 times -15, which is going to be 49 minus -120, which is 169. So we have 2 solutions since 169 is a positive number. Letter C, b squared minus 4b plus 4. A is 1, b is -4, c is 4. So we have 16 minus 4 times 1 times 4. 16 minus 16, which is 0. We are only going to have 1 solution when the discriminant is 0. And our last problem. 9n squared minus 3n minus 8 equals -10. We need to get that 10 to the same side of the equation as the rest of it. So we have 9n squared minus 3n plus 2 equals 0. A is 9, B is -3, C is 2. So, b squared minus 4ac. -3 squared is 9, minus 4 times 9 times 2. 9 minus 72 is -63. So there is no solution. Now let's just take a look. Let's think about when we have a positive number underneath our radical, we will have a positive and a negative solution to it. So we'll be adding and subtracting something. The square root of 0 is 0. So we are adding and subtracting 0. And can we take the square root of a negative number? No, not in Algebra 1. That's for you to deal with in a couple years. All right, we will see you all in class. Make sure you memorize the quadratic formula. I said it 11 times during this video. You need to say it about 100 more times.